Alright, so welcome to part 2 of our EPS sensor evaluation. So this is my Pegasus. As you can see, it's a good tool, has oscilloscope capability, but I don't go through the procedure of how to hook up this system because my battery is running low, it's not charging. I need to get this out of the way. Alright, so let us look on all the data that is processed within this car ECU. Alright, so we're looking at the thermistor temperature, and as I can see, it is 50 degrees, so it is not that hot. And then we look on the wheel speed left. So based on that reading, it is telling me that the information or the wheel speed data is coming from the wheel speed left from the ABS. So that information actually run through the CAN network and get to the EPS ECU. Then we have the wheel speed right, so both left and right wheel speed. So we need how fast the vehicle is going. So this will need to aid us in the quantity of assistance. The quantity of assistance the vehicle can go to doing. The quantity of assistance, the amount of assistance the electrical motor will give us based on the speed of the vehicle. And then we have right here now, which is a steering wheel torque. So this is a turning effort, and the reason why this thing is in negative because my steering wheel is not straight. You see it? As I turn the steering wheel, although the scan tool is on it, you can see the Newton meter. So this will be coming from the torque angle sensor. Alright, I remember say the torque angle sensor, it produces angle data and speed data. So how fast you're turning the steering wheel and forces torque angle. Alright, so engine RPM, this is coming from the powertrain module, and this engine RPM right here, this information is coming through the CAN network. So you remember when I told you that you have to be knowledgeable of all the system that operate the EPS. Alright, so engine RPM. Now we are looking at steering angle velocity, and alright, 9 degree. So we have the torque wheel, and then we have the steering angle velocity. Alright, so after we finish with the steering, then we have the amps, and this is very important for you to know the amps reading. The amps reading of the motor. This is very important. All right. See, when I steer it, the amp's supposed to move because it is consuming current. Well, this one is not moving. And after the amps current value, we look on the, I'll just move this. We look on the ignition power supply, and this is 13 voltage. This vehicle is on a charger. This vehicle is not running. If I should start this vehicle, I would should get something like 14.2. all right, and the motor actual current, which is this one, the motor actual current, this is the current the motor is consumed. So if I should turn the scan tool is gonna turn. If I should turn the steering, can see it go up to point. All right, so you can see the current that is being used by the motor. All right, and then let us go PIG power supply, PIG, I don't know what they call it, and then that's it. And then we have the steering angular sensor signal, and it said that is okay. So these are all the data value that is within our steering angle system. So we have to scan the system to evaluate the data. So our steering angle, our electrical motor, our ECU will be processing all the data. It's all working, and these are the three key components within all EPS system: steering angle data, the electrical motor, and the ECU. But since this vehicle is a CAN network system, could be a CAN or a FlexRay network system, this EPS depend on information like from the ABS on the wheel speed sensor. It require information from the engine, which is the engine revolution sensor. It require information from the yaw sensor, although the yaw sensor data should be here. I'm not seeing it. It should be here because this vehicle is equipped with electronic stability program control system. All right, I'm not seeing it, so I don't know. This is because, well, this is a 2017 vehicle, and I'm using a 2013 Toyota Camry hybrid software. So I would assume that the software on this scan tool is incompatible with the vehicle itself. But if I was using a more advanced scan tool or a factory scan tool, I will be seeing that yaw sensor data reading. And if you notice, I did not really go through the setting up of this scan tool. So since time permit, let I go through the procedure. All right, so right here is my OBD2 diagnostic connector. Of course, I remove the cluster, then I hook it up. When I hook it up, I'd come right here. And various scan tool work different ways. And then I go on vehicle selection, new vehicle, although this is white. All right, and then in this case I will choose USA Japanese. We have USA domestic, that is like Chevy, GM, Ford. USA Japanese, these are the vehicles that are imported from Japan that are sold in the United States. And my most advanced software right here would be 2013, and these are all the vehicles from Japan and Korea, of course, because Hyundai, Kia, and Hyundai and Kia and Toyota, I know for certain they have the similar EPS configuration where the ECU, the steering angle sensor, and the electrical motors underneath the steering column. I know that for a fact. But these are the rest of the vehicle. Then we enter Toyota, then we enter cars, then we enter Camry, and then, well, let me see, back. Well, I actually have hybrid L here. Let us try L. Hopefully that is not a hybrid. All right, good. And then let I go down here. So it seemed like initially I select the wrong vehicle selection. So let me see if it will work. And data stream, because I want to see all my data. Let's go on data stream, all data, and see it. My batteries have been showing red for a very long time, and now my system can go down. But the key thing is that I have, all right, so here it is: wheel speed, steering angle, revolution, steering angle velocity, steering wheel angle velocity, command value, ignition power supply, motor actual current. I'm seeing the same thing so far. Oh, well, it seems like I'm seeing additional information. So good. So let us go through these. All right. So you see the difference when you select the correct data. All right. So we stop at steering angle sensor signal. That's okay. This one is on thermistor 50 degree. Torque sensor output voltage, that is 2. All right, let me come back up here. Go torque sensor output signal, that is okay. Motor voltage, motor terminal voltage, so that is the voltage is going to the motor. All right, And I notice one is U and one is V, so I would assume that's what, the left and right. And we are just looking through these data. Motor terminal voltage, motor torque voltage, motor torque to 0.2 voltage, motor torque to motor voltage supply, ignition, on off numbers of times 730 times, command value, motor angle, motor rotation angle. Alright, so that is the motor rotation angle. Command value, we went through that already. Motor actual current, just ease up this. Alright, so when I turn, we can see a difference in current. And after then we have a rotation angle sensor average. Alright, and this all information is coming from the steering angle. Rotation sensor average sine. Oh, this is soccer tower. We've gone into some geometric drawing or some trig right here. So we have some sines, and we have cos or cosine, as what we would call them. Motor overheating limit, never overheat yet. Assist limited count, power volume low, prevention limited. Alright. So let's continue. Assist limited record, cycle, and record 2 key cycle assist. Alright, power assist signal on. So these are all the data. I'm not seeing the steering. I'm not seeing the yaw angle sensor data. So these are all the information that our scan tool can show us. And in summary, let me just summarize this now. So here is our system. This is our scan tool. Our system is good to go so far. And ensure that there is no failure when I start this vehicle right here. See, there the lights are out. The EPS light is out, so there is no failure within this EPS. If the system was defective, the EPS light would come on. So come now. So let us just summarize this. Let us just summarize this. Alright. So we explain the main purpose of electronic power assist steering, and the EPS is to aid the driver in steering, and it's also, the EPS also contribute to other things like the braking system and other system too. Identify 3 parts at it. We identify the 3 parts, which is the steering angle sensor, the electrical motor, and the ECU. And in this particular case, our unit is built in one. It's a compact unit. So if there's a failure in any one of them, in most cases, you just change the entire unit. Although to an extent it can be disassembled. Alright, we inspect for any failure within the system. We don't see any loose connection, we don't see any loose fitting, we did not see any crack or any deformation, any physical failure within the steering column mechanism. Alright, that is very unlikely, but it is possible because sometimes it might have manufactured defects that can lead to crack or some form of deformation of material. But we didn't see any of that. explain the operation of the alright, so we did explain the operation of the electro-hydraulic system, which is the EPS. We said that it comprises of a steering angle sensor. Whenever you turn the steering wheel left or right, that information is then sent to the ECU, and based on information that is coming from things like the ABS, the yaw angle sensor from the powertrain management system, when all of those information go to the EPS ECU, it will determine how much assistance the electrical motor will assist the driver within the steering. Alright? So you know that. We look at the advantage of EPS is that EPS have some form of autonomous system pertaining to if we steer too fast to the left or to the right, the ECU will process that, and with the information from the yaw angle sensor, it will determine if the vehicle is oversteering or understeering, and this can apply a brake and cut engine power. So with an EPS system, it is some form of autonomy that can happen within the system without driver intervention to ensure that the vehicle is controlled properly. The limitation is that it is expensive, it is complex, it requires training and knowledge, and you have to be knowledgeable about the ABS system, the powertrain management system, the electronic stability program system, in order for you to repair these type of advanced vehicle EPS system. Alright, we evaluate the sensor data, and we have identified all of them so far. We have identified the wheel speed sensor. Those information will be coming from the ABS system through the CAN network. We identify the power supply, which is very important to the ECU. We identify the engine RPM. So that to show you that the engine RPM, the ABS, is sending information to the EPS. The only information that we did not identify was the yaw angle sensor, the yaw angle rate, and that should be 0. So if you're scanning a vehicle and you see yaw angle, it should be 0, unless if the vehicle is crab walking or the vehicle misaligned or something. But the yaw angle should be 0 at all times. And so that's it, and thank you for having me. So good.